Please take out this note to follow along with the lesson. Up until now, the only trigonometry we've used is for right triangles, or triangles that have a right angle in them. But what if the triangle doesn't have a right angle? This is where the sine law comes in. Before I show you the sine law, just remember how to label a triangle properly. Here's a generic triangle, ABC. Capital letters are used for the angles. Lowercase letters are used for the side lengths, and we use the same letter for opposite sides. So the side that's opposite angle A is side A. The side that's opposite angle B is side B, and opposite to angle C is side C. So these are just generic labels. I've chosen to use A, B, and C. You could have a triangle labeled X, Y, Z, or any number of combinations of letters that you want. The key is, for proper notation, the opposite side has the same letter, just lowercase. The sine law is what we're talking about, and this is a way of solving for angles and sides in a triangle that doesn't have a right angle. And the sine law states that the ratio between a side length and the sine of its angle is the same for each set of sides and angles. So if we compare the ratio between the length of side A and the sine of angle A, it's the same as the ratio between the side length of B compared to the sine of angle B. And it's the same for side C and angle C. So that's the sine law. So here I've written it with the side lengths on the top of the fraction and the sine of the angle on the bottom. As long as you're consistent with how you're writing it with all the fractions, then it's fine. You could also write it like this, where we have the sine of the angle on the top and the side length on the bottom. Either this way or this way of writing it are both valid. It doesn't really matter as long as you're consistent having all the side lengths on the top or all the side lengths on the bottom. You don't want to have a side length on the top for one and a side length on the bottom for the other. That would not work. So I'm going to show you some examples to show you how to use the sine law to solve for side lengths and then also for solving angles. Example 1. Find the length of side C correct to 1 decimal place. So where's side C? Well, here's angle C. So the opposite side is side C. That's the side length that we're looking for. Now, if you look at the sine law, the way it's written, you need to have a complete pair, a complete set of a side and its angle in order to solve. So here I want side C. I have its opposite angle. It's 25 degrees. But in order to solve for side C, I need to match it up with an equivalent ratio. Here I have a side length. That's the only side length I know. So I need this angle in order to have a complete ratio. Well, if I know two angles, I automatically know the third one because they have to add up to 180. So my angle A is 107 degrees. Okay, so now I have a complete set, an angle with its opposite side. Now I can use the sine law. So the way I do this is first I set up my unknown. So my unknown is side length C. It matches with angle C. So I'll start with that. So I have C over sine 25. Then I need to set that equal to another ratio. I've got my side length on the top, so the other side length that I know is 36, and that pairs up with sine of 107. So I have C over sine 25 equals 36 over sine 107. Now I just have to solve this proportion. And if you recall our lesson on solving proportions, you'll remember to solve for the unknown, you cross multiply, so multiply the diagonals and divide by the number left over. So C is equal to 36 multiplied by sine 25 divided by sine 107. And when you do that in your calculator, you should end up with C is equal to about 15.9 centimeters when we round it. If you didn't get that answer, you're probably inputting the numbers wrong in your calculator. You should ask me for some help with that before moving on. But if you got that, you're good. We can move on to the next example. So here's example 2. Solve for angle B and angle A. If you look at the diagram, angle B and angle A are just the two missing angles. We know angle C is 45 degrees, and we know these two side lengths are 3 and 2. So let's start with angle B. What does it match up with? Well, the opposite side, 2. So we want angle B. We know its matching side is 2. We have a 45-degree angle. It matches up with the side length 3. So we can start with this proportion. Angle B matches with side length 2 because they're opposites. Angle 45 degrees matches up with side length 3 because they're on opposite sides of the triangle. So now that we have a proportion, sine B is my unknown. So I'm going to cross multiply and divide. So sine B is equal to 2 times sine 45 divided by 3. And when you do that in your calculator, you'll get an answer of about 0.4714. A lot of people are going to stop at this point and they're going to say, well, angle B is 0.47 degrees. Or they'll take it as some sort of a percent and say it's 47 degrees or something like that. And that's wrong because remember, this is not angle B. This is the sine of angle B. So if we want to get the angle B, we have to do the next step, which is take the inverse sine of 0.4714. So angle B is actually equal to the inverse sine of 0.4714, which is about 28 degrees when you do that in your calculator. So we've got angle B is 28 degrees. Now, the question is still asking us to solve for angle A. We could go through a similar process using the sine law to find angle A, and if you want more practice using the sine law, you can certainly go ahead and do that. However, notice this. We know two angles now. That means we can figure out the third angle, knowing that they all have to add up to 180 degrees. So angle A is 180 minus 45 minus 28. It ends up being 107 degrees. So if you got all this, congratulations. If you got stuck on a few parts, let me know and I can help. Otherwise, move on to the next example. Here's example 3. Solve for the value of h in the following diagram. So here I have a large triangle made up of two smaller triangles. The entire length of the bottom is 68 meters. This is a 43-degree angle. This is a 56-degree angle. There's a right angle between the two smaller triangles. H is the height right here. So I'm going to encourage you to pause the video and try to solve this problem on your own. And once you think you've got an answer, unpause the video and see how you did. I started to solve this question by noticing that in this large triangle, I have a side length, and it's not a right triangle. So I can use sine law if I know what this angle is. So my first step was figuring out this entire angle here. If you were getting stuck, getting started, see where this takes you. Now you can use sine law in the large triangle. My next step was using the sine law in the large triangle to figure out this side. And now if I look at this smaller triangle, I can use sine law to find the value of h. H matches up with angle 56 degrees. This x value, which was 47 meters, matches up with the 90-degree angle. So I end up with my sine law and I solve. H is about 38.9 meters. If that is what you got, great. If not, let me know how I can help you to figure out where your thinking was off. Otherwise, move on to the practice questions and ask questions and let me know how I can help.